morning. We're coming to you from Las Vegas today. Las Vegas is not just the Sin City. Today we'll be showing you another side of Las Vegas and the people that make Las Vegas another kind of place to live. Today Las Vegas is made up of students, faith-based organizations to bring a dream come true. As you may know, January 12th, 2010, there was a devastating earthquake of 7.0 magnitude. What that did is that put 1.5 million people homeless. What we're doing today is we are building houses. Each of these booths is a production of building a wall. The walls will be assembled together to build a house. One of my dearest friends, Ted Ciotti, and I just wanted to introduce Ted to the world here. He's done so much for mankind and humanitarian purposes. So say hi to our friends, Ted.
Thank you, Oscar. Hello, everybody. Been in disaster relief for over 10 years, probably going on 15. We've done a lot of work all over the world, from the Philippines to the Middle East, and I'm just happy to be involved in this project and to help everybody here with the Haiti project, and then to take this to the next level, to not just Haiti, but to the other parts of the world with various different technologies, all designed to help humanity to move things forward, to increase standards, and to provide better environments for families across the world.
I'd like to introduce you to Rick. Rick, please tell us a little bit about you.
Sure, Oscar. It's a pleasure. Thank you, Oscar, for coming. It's really great to see you again. And Oscar, this is really a very, very exciting day for all of us here. This is a prototype build for the Help Build Hope Haiti project, and it's a prototype of the exact home that we are going to be producing in Haiti, which is going to be taking place later this year. And I say home, but this is part of a 5,000 home project that we are going to be bringing to Haiti over the next 5 years. UNLV in our background here is this is the School of Architecture, and what we have here today is the student body from the School of Architecture who's come out and volunteered, come alongside of us to do the prototype. I'm going to walk you through kind of quickly here how this is set up and how it works. This is really just a mock build for what we're going to be doing throughout the country over the next 5 years, going into 25 to 30 major cities, engaging hundreds of thousands of volunteers to do exactly what the students are doing here. And I want to just point out that there was no training involved. Everybody just showed up today and said, okay, let's go to work. And it's really, I think you're going to be amazed at what you see. What we do first is we set up a staging area for all of our materials that we're using to build the homes. And obviously you can see 2x4s there in front of you. We have fiber cement board, which is a cementous type board. We have some plywood type material and some expanded polystyrene foam. These are the major components that go into the wall elements for the homes that we're going to be building. And as you can see here, this is not a typical construction site. We have elevated work platforms, because really what we're doing is a manufacturing operation here. And rather than having people bend over like you would see at a typical construction site, because here in America, I hate to say it, we're not a stooping and bending society, we're working off of a table. We can be very precise that way. And these tables here, the first tables are our cut tables. We're still building these houses in a way, kind of the old-fashioned way that houses have always been built throughout the world, and America especially. We have guys here cutting 2x4s. That are fit specifically into the different panel sizes that are being produced. So, and everybody has, as you can see, there's some workbooks here. Each station has a workbook. We've designed this to work very simply, really the same way as if you've bought furniture at IKEA, you get it, it's knocked down or it comes in parts. You get then a book inside that tells you how to put it together. Over in this area here, we're now coming to the panel assembly location, where the panels go together. And what we have here, we've built a template that receives the 2x4s and automatically squares them up when they go into production, and we apply our skin to them or our sheeting to them. You're seeing the application here of the panel assembly with the sheeting on it. This panel is now done. It's ready to move on to the next location, which is the final location. As you can see, we have students here, girls and boys, men and women alike. At our build function, this is designed so that you do not have to be a skilled tradesman to come to work to build a panel.
Look at you, runner.
Quite frankly, you could actually come here and help us build a panel even if you're in a wheelchair. We will.
One minute, Joe.
Okay. Now I'm going to ask everybody to kind of push down, push it down. Go ahead and put it right inside. And just push it down good. Okay, push it down. Push it down real good. Makes it stronger than any wood frame wall, stronger than concrete block, not as strong as reinforced concrete. Reason being is this all becomes one, and the foam becomes a structural element, and it does something really cool. It does a whole lot of cool things. First of all, prevents a cavity from any vermin, insects or whatever, because it's treated with a zinc borite. This application over here, if you take a look over here at this particular panel application, you can see someone with a caulking gun. That's a very special adhesive that's made specifically for adhering expanded polystyrene foam to a structural panel. The foam is going in. You can see them pushing it in. It fits very snugly. It's very important from the standpoint of how that polystyrene foam is applied to the panel itself. Where they then are putting a little bit of force on it, pounding on it, getting the adhesion to take place. It's now ready to receive the final skin, which is the fiber cement board. And the other thing is, for both earthquakes and hurricanes, this is like a built-in shock absorber. If the earth shakes and the building shakes, this will take the shock and cause it to basically bounce off. Cause it to just simply move but not fail. The problem in Haiti was catastrophic failure with concrete. The buildings collapsed, crushing people. The buildings will not collapse. They'll stay together as one. If something does fall down, this is not really heavy enough that it's going to take somebody out, but it will stay together as one.
Okay, everybody!